We'll now talk about command substitution. Command substitution offers an added bit of flexibility in regards to scripting and variable assignment. With command substitution, we can echo the contents or output the contents of a given command, store it in a variable, or just make use of it. So it's a nice way to function. It functions like a redirect. It is a redirect. It's a special redirect that the bash shell performs on a given command that's run within the proper syntax. Now typically, in order to enable command substitution, you run a given command using backticks or the $ and parentheses, open paren, close paren, and we'll show you some examples. So it allows us to run a command with the output of another one, essentially running the command and substituting the command itself for the command's own output. Sounds a bit confusing, but you'll see what I mean. The important part in regards to scripting is that you can set variables to the output of commands that can be very long or very short. Generally speaking, you run commands and you may do a word count to get a number of lines or to check an error level or something to that effect to store it in a value as you're going through your script. Let's open a shell and we'll show you some examples of command substitution. Now, command substitution is one of the expansions performed. Recall we've shown you brace expansion, we've spoken about tilde expansion, and command substitution is yet another expansion that bash performs for us. Let's show you an example of that. We'll go into temp2 because that's the directory we've been working in. Temp2 contains a few files such as data, data2, data3, and a bunch of other things. So what we'll do is as follows. We'll lsl, and by default that lists the directory. That's what we see here. No big deal. Clear the screen. This time what we're going to do is we're going to lsl and we're going to use command substitution to drive the path that the ls command is supposed to use. Now we've predefined a file. We've created a file called lspath.txt. It's lsl, it's right here. lspath.txt contains one line. We can cat its contents or echo it, either or. If you echo, you need to use the redirect. Cat by default reads from the file or from a file. And as you can see here, lspath.txt has a path, and that path is /etc. Now here's a very rudimentary example of using LSL with command substitution. We'll do LSL. Now by default, if you don't specify a directory as an argument to ls, what ls will do is list the contents of the current directory. That's no different than dir in DOS, etc. We'll LSL and we'll open backticks. Now backticks are typically, at least the open backticks, these are also called reverse quotes or back quotes, are located, or the main backtick is located, and you use it twice, right next to the number 1 key. And you usually don't need to press shift to enable it. It's the same key that shares the tilde. If you press shift, you'll enable a tilde, like so. If you don't use shift, you get a backtick. So we'll LSL, and within the backtick, or back quote, or reverse quote, we can run a full-fledged bash command that bash will expand for us, unbeknownst to LSL. So the ls command doesn't know what bash, or won't know what bash will do with the backtick. Bash will just perform the expansions and run ls x number of times for each instance of valid values that are found within the expanded file. So what we'll say here is as follows. We'll tell it to cat lspath.txt, and it will close with the same backtick, same direction. So what's going to happen here is as follows. ls will run, but it won't list the current directory. It'll take its instruction or its argument, its default directory argument, from the expanded command, which is to cat lspath.txt. Now note, when we ran cat lspath.txt before, it outputted the contents of lspath.txt, which currently contains one line /etc. So this /etc will be substituted for the argument that goes here. This is what we mean by command substitution. The output of cat space lspath.txt is equivalent to /etc. /etc will be presented as an argument to the ls command. Now, if the lspath.txt file contained many directories, then the bash shell would essentially run ls x number of times, or n number of times. And we'll show you an example of that shortly by including a different directory for ls to operate upon with the help of command substitution. So this is the power of command substitution. So let's proceed. Now look at what follows. This is a listing here of the files and directories that are within the /etc directory. You know that these directories don't exist in our current directory. You can even tell by some of the names. Just look at some of the names, especially the ones ending with conf for configuration. That tells it, that gives it away right there. We'll go down, and it's listed for us the contents of that directory. And you can still make use of pipes if you'd like. You don't necessarily need to echo the output of the command substitution to stand it out, which is the screen. We could tally it up using our favorite word count with the list option, and then we get a listing of the number of entries or rows that is returned as a result of the result set. So great. So that's a simple example of command substitution. We run a command, we substitute output for an argument, and then it's returned to us on the screen, which we could then take and parse in any way we'd like using pipes, redirection, etc. Redirection also comes in handy. For example, let's say you wanted to redirect the output of the command substitution we're doing here, instead of to the screen, to a file. Let's just simply specify greater than to create a new file, and this file we'll call etc listing.txt. Excellent. So now if we LSL this directory, you'll see there's a newly created file called etc listing.txt. We can cat its contents to see what's in there, and it's all formatted. It lists everything for us, and it's sizable as well. It's 14K in comparison to the other files, which are all under 50 bytes. Excellent. So that's one example. Let's show you another neat example. Now, when you write scripts, you tend to set variables, or we tend to set variables so that we can cross-reference the variables throughout the duration of a script. So let's show you how you can use command substitution with the ability of bash to set variables. We can define a variable that contains the output of all of this stuff here. So let's say, for example, a new variable, etc_dir, and we can check that whether or not it exists by doing a set grep etc_dir. Nothing exists. So let's set etc_dir is equivalent to, and the way you set a variable within bash is quite simple. You just type the name of the variable, followed by the equal sign, no spaces. You don't want to do this. This is invalid. So it's the name of the variable, and the case is not sensitive here. You can use upper or lower or combination, but typically speaking, it's good to use uppercase, but you can use anything you want. etc_dir equals backtick. Whenever you want to invoke command substitution, consider using backticks or the dollar sign. Backticks are just much easier to remember. etc_dir is equivalent to backtick LSL/etc. And of course we could perform nesting here if we'd like, but we'll make it simple. So what's going to happen here is as follows. A variable called etc_dir will be set, and it will house the listing of /etc. No different than the etc listing text file here. Excellent. Let's proceed. Now there's a new variable. If we set grep etc_dir, there it is. Don't be surprised by the format that you see here. The formatting by default is ugly, and we can fix it. If we were to echo etc_dir, now if you want to reveal the value of a previously defined variable, prefix the variable with a dollar sign. That's the standard delimiter for variables within a bash environment. So you can echo etc_dir, and you'll see it echoes the contents in an ugly format. Let's show you how to clean it up. If you want to preserve the formatting, simply enclose your variable etc_dir within quotes, and then the formatting is preserved. It's that simple. So you don't lose the formatting when you set the variable as we did earlier using the backticks, the command substitution. Excellent. So you understand that. Now we can set another variable. We'll show you another way to invoke command substitution. Let's set another variable called etc_dir1. And this time we'll use the other form of command substitution, the other accepted syntax. and it's prefixed with a $sign and then open paren and then close paren. It's that simple. This will function in the same way. So now we have two variables set. We can grep for etc, and we have two of them set. Let's echo etc dir, that still exists, and let's do dir1, that exists. Excellent. And once again, it's all preserved. The formatting, that is, if you enclose the output when you echo it using quotes. So there are two formats for invoking command substitution. By executing backticks, as you see here, so a command such as anything you'd like within backticks, or by using the $sign, open paren, close paren. Either or will work. Both of these are acceptable forms of command substitution. And once again, within scripts, you make use of command substitution all the time when you want to, especially when you need to get numeric values based on items on your system. Let's do some other things. Let's say we want to create a count, a variable called temp2count. We're currently in the temp2 directory. Let's say we wanted a count of all of the, and these are simple things, but you'd be surprised how simple shell scripting can be when you make use of features such as command substitution. Let's say we wanted a count of all the files that are in this particular directory, or entries, which could include files or directories. We could set it in a variable for use later on. We don't necessarily want the full output with all the permissions, ownership, group ownership, user ownership, etc., date, timestamp. All we want is the number of files in this particular directory. So we'll set a variable, we'll call it temp2count, because we're in a temp2 directory. It could be anything you want as long as it's unique. If it's not unique, it'll overwrite what's there. And then we open with backticks, and then we run the command. We'll do ls-a. As recall, I mentioned -a, the capital A before, so that it omits the implied dot for the current directory and double dot for the directory above. And we'll pipe, of course, this to wc-l to count a number of lines, and that's it. Now we have a new variable called temp2count. If we're to echo temp2count, you'll see it doesn't actually contain the contents of the directory, just contains a count. Now within your script, you can always cross-reference temp2count. Let's say, for example, you're checking this directory to see whether or not it changes. You could write a conditional that says if temp2count is, let's say, greater than 10, then do something, or less than 10 or equal to 10, do something. That's the power of being able to use command substitution to assign a numeric to a placeholder, which we can later use. So that's another example. There are quite a few other examples. Let's say we wanted to have the ls command list multiple directories. Let's say there were certain directories on the system that we always wanted to keep tabs of. Well, just modify your lspath file, pico lspath, or vi or whatever, and just add the directories that you're interested in. Let's say we're interested in etc and /bin. Well, now if we were to run the command we ran before, lsl, use backticks or the other format with the $sign, cat lspath.txt, and you can tab it out. Remember, bash supports tab completion, so don't need to type out every command. Now what will happen, lsl will actually list the contents of etc as well as bin, because the command substitution is at work. Bash will essentially invoke ls twice. So here we have both. Now it looks like etc alone ran, but bin comes before etc alphabetically, so bin was listed first. Here's the listing of the bin directory. All of these things you see here in green are executable. This is the first listing for bin. The second listing corresponds to etc. As you can see here, we began with bin, and then it went down to etc. And you can keep expanding the lspath file, the .txt file, to watch the directories that you're interested in. And this doesn't just apply to the ls command. The ls command is probably the most frequently used command because we're always looking at the directory listings and file listings. But you could also use any other system command such as du to get disk utilization. So for example, we could do du, h for human readable, backticks, cat, lspath.txt. So now du will be invoked twice for both directories, or once for each directory. Once for etc, once for bin. Excellent. So that's another example of command expansion. In this case, DU didn't actually sort alphabetically, but that's not a problem. And there are all sorts of uses. Let's say, for example, you wanted to monitor, and I came up with this example. Let's say we look at our netstat table, and this particular system is running the HTTPS service, Apache SSL, port 443. Let's say this is a critical system, and if for some reason 443 goes down, SSL, you want to be notified about it, or you want to store the value somewhere because you have a script that monitors it. There are more elegant ways to do it, but here's a simple way using command substitution. You could set a variable, such as SSL status is equivalent to, of course, backticks, netstat, ANT, which is what we just typed to show TCP connections, grep, port 443, then send that to WC for word count with the listing, backticks. What this will do is as follows. Word count will tally up this line. Right now it is running, it's successful, so it'll return 1. So within your script you can always check for that 1. When it's no longer 1, such as 0, because it'll be 0 when it's not 1, then, or undefined, then you know something's wrong. So now we have a variable called SSL status. Let's echo it. Another thing, tab completion also works for variables that are set. That's another neat trick or neat thing to know about Bash. If you set a variable like we just did with SSL status, you can just tab it out. Now currently SSL status is set to 0. We've netstatted it, we've grepped the wrong port. And that makes sense because let's say, for example, there's a port that you're watching and it's stopped. In this case, we just pretended with 442, which doesn't exist. Run the same command again for port 443. It's set, and if we echo it, it's now 1. Recall, if you reassign a variable, it simply overwrites what the previous setting was. So now SSL status, no matter how we refer to it with the script using conditionals, etc., it's 1. And the second HTTPS is not running and we happen to perform the check, it'll be 0, and then we know something's wrong. So that's yet another use of command substitution. Another way you can use command substitution, let's say for example, is to store in a variable, let's say the file list. You may have a file list, or you may have a list which contains a bunch of entries, and you want that list stored in a variable so you can operate on it using, let's say, like a for loop. That works out pretty well as well. So for example, you could touch a file, create a file called list.txt and put a few entries into it. Let's say echo Dean into list.txt. We can echo Davis into list.txt. And now if we cat list.txt, we have 2 entries, Dean, Davis. Now a for loop can easily run through this loop here. The looping mechanisms within Bash can easily loop through the values here to do some comparisons or some checks for you. Well, we can set a variable to the value of list.txt. Certainly, Bash has the capability of opening the file and going through the values, but you can also set it to a variable. So you could say, for example, file list. Remember, when you set variables, no spaces. And I keep mentioning variables because we set them all the time when scripting, so might as well get used to them. File list is equivalent to backtick, and here we could either say cat, or we could just use the less than sign for redirection of input, list.txt, close backticks. Now we have a variable called file list. If we're to cat file list, or echo file list in this case because it's a variable, you'll see there are 2 settings. And any trailing new lines are cut off. Nonetheless, there are 2 values here that a loop could loop through. 2 separate, distinct values that are now set within this variable. And we can check the variable which is in memory and not on disk. So you incur the read once and then move on. So command substitution allows you to substitute the command that you run with its output. And then the output can be used with any other command. So it's a special form of redirection that comes in handy for all sorts of checks and balances within your scripting environment. We'll be using command substitution here and there depending on what we're trying to do with the scripts that we're writing. But once you have a sense for how it works, then any task that comes up that may require command substitution will be obvious to you, that you could essentially echo the output of something, store it into perhaps a variable using command substitution via backticks, and make use of it.